In this lesson, we will go further in depth into solving radical equations. So these radical equations will have more than one radical. This is the same steps that we just went through in the last video, so I'm not going to go through those steps with you. For my first question, these are the kind that we kind of like because they're pretty straightforward. Both side is a cubed root, so I know if I take this side to the third power and this side to the third power, that all of my radicals will go away, and it's a simple algebraic equation. So cubed root and cubed gives me x plus 6. Cubed root and cubed gives me 4 minus 3x. And now I'm just trying to get x's to one side. So I'm going to add 3x to each side. And that leaves me with 4x plus 6 equals 4. Subtract the 6. That gives me 4x equals negative 2. So dividing by 4, I get negative 1/2. Now I'm going to check that solution. And that gives me the cubed root of negative 1/2 plus 6. Getting a little sloppy. And then the cubed root of 4 minus 3 times 1/2. Sorry, times negative 1/2. Negative 1/2 plus 6 would be 5.5, which is going to be ugly, but we don't need to worry about that. Over here, I've got a minus and a negative, so these are actually going to end up adding together. So it's going to be the cubed root of 4 plus 3 times 1/2 is 1.5, so 5.5, which I of course could have written those as 11/2 or the decimal equivalent, but in essence we have the same thing, and so that is an actual solution. So my solution is x equals negative 1/2. This question is a bit more complicated because if you'll notice, I do have two radicals and they do have the same index, which is great, but I've got this extra thing here, and that's going to make things more complicated. So in this question, I have to decide which of my radicals I want to isolate. I'm going to choose to just add this whole thing, which is basically me moving it to the opposite side. I'm getting it out of the way, which means on the left side, I've got this radical 3m plus 1. On the right side, I have 1 plus radical m plus 4. Now, just as I did on the last question, I'm then going to square or take it multiplied by whatever the index was, which is a 2. And on the left side, that just gives me my 3m plus 1. On the right side, it gives me a whole mess because I've got 1 plus radical m plus 4 squared, which means I'm really taking it multiplied by itself. So I'm foiling this out with a radical. So 1 times 1 is 1. 1 times radical m plus 4 is radical m plus 4. And then radical m plus 4 times 1, that gives me 2 of them. So it's radical m plus 4 twice, so 2 radical m plus 4s. And then when I multiply these two, it's essentially me squaring it, so then I just get m plus 4. Because this would give me, those two multiplied would give me radical m plus 4 squared. So I did something great. I got one of the radicals out of the way. Notice this is out of the radical, but I still have one that I have to deal with. So now let's try to get this one by itself. So let's keep it on the right side. Let's get rid of this m minus m minus m. And that gives me 2m plus 1 equals, and on this side I'm going to combine that 4 and that 1 to 5. So it's 2 radical m plus 4 plus 5. Let's get rid of that 5. So that leaves me with 2m minus 4 equals 2 times the quantity or the square root of m plus 4. So now I'm to a point where I kind of know how to do this because I've done a question like this. I'm going to square these again. And on the left side, that means that I'm foiling, and that gives me 4m squared minus 16m plus 16. Whoops, forgot my 1. And on the right side, it gives me 4 and then m plus 4. So now all of the radicals are gone, but I've got a lot going on still. That leaves me with 4m squared minus 16m plus 16 on the left, and then 4m plus 16 on the right. I'm going to subtract 16 from each side, which is going to make them go away on each side. And I'm also going to subtract 4m. And that's going to leave me with 4m squared minus 20m equals 0. So I always like it to equal 0 when we're dealing with a quadratic, or that's that squared term. I'm going to take out a common, a GCF, greatest common factor, which in this case would be 4m. And that leaves me with m minus 5. And now I would set each equal to 0. So 4m equal to 0 gives me that m is 0. And m minus 5 equal to 0 gives me that m is 5. Then of course I would plug it back in to check my solution. Now I've run out of room to show that, but let's just do it mentally. If I take 0 and plug it in, I get 0 plus 1, and the square root of that would be 1. And I would plug the 0 in here, and that would give me 0 plus 4, which is 4, and the square root of that is 2, so minus 2. Does that equal 1? No, it doesn't, because 1 minus 2 gives me negative 1. So 0 is an extraneous solution. It does not work. Let's try 5. 3 times 5 is 15, plus 1 is 16. We know the square root of 16 is 4. 5 into the other one. 5 plus 4 is 9. Square root of 9 is 3, so minus 3. Does that equal 1? Yes, 4 minus 3 is 1, and 1 does equal 1. So m equals 5 is my solution. Whew, 2 for you to try on your own. The first one should be pretty straightforward. The second one might take an entire screen of work, but press pause, try both questions, and then press play to check your work. For the first, again, I'm just going to cube each side here, and that gives me 2y minus 1 equals 10y plus 3. I'm going to subtract that 2y, so I'm going to get all of my y's to one side. I'm going to get all of my constants to the opposite side, which gives me negative 4 equals 8y. Then I will divide to get negative 1/2 equals y. Of course, then I would plug it back in and check it. I'll let you do that on your own. This one works. For the other, I would move this radical to the opposite side. So I would have radical 3x plus 1 equals 2 plus the square root of x minus 1. Squaring each side would give me 3x plus 1 on the left, and on the right I would have 4 plus 2 of these, and then plus x minus 1. I would try to do a little bit of cleanup here, so I would subtract the x from each side, which would give me 2x. I have 4 and minus 1, so I have 3 on the right side, so I'm going to subtract the 3, which would get rid of all of that. And then 1 minus 3 is negative 2. Yes, I'm not showing a lot of my work here because I don't have a lot of room. And this is what I come up with at this point. On this one, I think I'm going to go ahead and divide by 2 before I square each side, because I see that I can rewrite this as 2 times x minus 1, and this is 2 times all of this. And so I can divide each side by 2. So now I'm going to square, and I won't have that extra 4 in the way. So if I square this side, I'm foiling. I get x squared minus 2x plus 1. If I square this side, I just have x minus 1. Subtracting the x gives me minus 3x. Adding the 1 gives me plus 2. And now I'm going to factor this into x minus 2, x minus 1. That would give me a solution of 2 and of 1, and I would have to check both. Checking the 2, I'd get 3 times 2, which is 6, plus 1 is 7, so the square root of 7, minus, plugging in the 2, 2 minus 1 is 1, so minus 1 equals 2. And if I add 1 to each side, I mean, obviously I can tell right away this isn't going to work because the square root of 7 is a decimal, and if I add 1, I get radical 7 equals 3. Not true. For the other, if I plug in 1, 3 times 1 is 3, plus 1 is 4, so the square root of 4, minus 1 minus 1 is 0, the square root of 0 is 0. And does radical 4 minus 0 equal 2? Yes, because that would be 2 minus 0, and that equals 2. And so 1 is my only solution.